In today's video, we're going to be talking about different types of real numbers. So if we look at our title, Comparing Real Numbers, it says skim the examples for lesson 3D, that's this lesson. Predict 2 things we'll learn about real numbers. So if I kind of look through here, I see a Venn diagram. So I'm going to learn about how to use a Venn diagram to organize real numbers into different categories. And let's see, what else can I pick out here? Oh, I could pick out maybe a couple of different words. I might learn about irrational, whole, integer, rational, and real. So we will learn about real numbers vocabulary. Okay. So in this section in the vocabulary, it says fill in each blank with the correct term or phrase. So numbers that are not rational numbers, okay, are called irrational numbers. And remember, we talked about last week, another name for rational numbers are fractions. So we can kind of put a little star over here. All rational numbers can be expressed as fractions. Okay. So again, rational numbers, those are any number that can be expressed as a fraction. The real numbers, so the set of rational numbers and irrational numbers together make up the set of real numbers. So if you think about that Venn diagram, you have a set of real numbers, that's everything. These are the real numbers, and you have 2 different kinds. You've got rational numbers and you've got irrational numbers. So the real number system, it takes up those 2. Okay? Alright, so first example, it says name all sets of numbers which negative 18 and 11 square root of 11 belong to. Answers may include irrational, whole, integer, rational, and real. So you may need to refer back to that PowerPoint we worked on in class. Okay? Or you can look at this little Venn diagram over here. So let's think about negative 18. Whole numbers we know are going to be 0 plus all of the counting numbers. So 0, 1, 2, 3, 4, 5. So since 18 in this example over here is negative, it's not going to be part of that whole number system. However, it is going to be part of the integer system. So negative 18 is an integer. Integers start including the negatives. Okay, and if it's an integer, integers are part of the rational numbers. So it's going to be an integer, it's going to be a rational, and all rational and irrational numbers are part of the real number system. Okay, 11 squared root of 11. 11 is going to be a number that we can't represent as a fraction, or it can't be represented as a repeating or terminating decimal. So since it doesn't fall into that fraction category, it's going to be an irrational. Okay, and all irrational numbers are also real numbers. Okay, vocabulary link. Irrational is a word used in everyday English. Look up the definition. How can the definition help you to remember the mathematical definition? So let's think about irrational. If you think of somebody who is irrational, they might be not able to think clearly through a situation, they're not able to process information, they're acting irrationally. Maybe think about a little 2-year-old having a temper tantrum, irrational, and I like to think about it as somebody who maybe doesn't use logic. So something that's irrational is without logic or order. And how might that help us remember what an irrational number is? Well, irrational numbers, in addition to being able to be expressed as fractions, irrational numbers are also decimals that either terminate or stop. Terminate means stop, or repeat. Okay? So numbers that terminate or repeat, they have a specific order. They stop, so there's order in that, or they repeat in a pattern. So they do have that logic and order, so order being that key word there. All right, let's look on to the next page. We have our nice Venn diagram. It says place the numbers below in the Venn diagram. So -6. -6 is an integer, but it's not a whole number. 12. 12 is a whole number. It's not negative, and it falls into that category of counting numbers. All right, 1/10. That's a number that can be expressed as a fraction. So that's going to go inside the rational numbers category. Square root of 2. If I were to put that into a calculator, I'm going to get a decimal that does not repeat and does not stop. So square root of 2 is going in the irrational numbers. If you look at 0.12333333333, that's a decimal that starts repeating. Repeating decimals go in the rational numbers category. And I'm going to put a little line over that 3 so I don't have to write it all out. 5 pi. We know pi is 3.1415926 and on and on and on. It does not terminate, it goes on forever, and it does not stop. That makes pi irrational, and therefore 5 pi is also irrational. 14%. If I think about 14%, I can convert that to a decimal, 0.14. That's a decimal that stops. So it fits in the rational numbers category. 14%. And 3/7. Again, that's a fraction, which makes it a rational number. So 3/7 fits in the rational numbers category. Okay, we're going to skip this bit about comparing and this bit about ordering from least to greatest. So we're really focused on the vocabulary in this lesson. All right, helping you remember. Think of a way to remember the relationships between the sets of numbers in the real number system. For example, think of a rhyme, draw a picture or diagram, or use a mnemonic device. I like to think about this as the sea of reals. So if you think about underwater, okay, a sea, we have different sized fish. We have the smallest fish. He's kind of like the prey, right? And this one's not in the Venn diagram. This is the natural numbers. And those are all your counting numbers, 1, 2, 3, 4, 5, and so on. Okay? And then we have a bigger fish who could definitely eat that little prey fish. Okay, so you draw some little teeth on him. This is going to be the whole numbers. So that includes 0, 1, 2, 3, 4, 5, and so on. So it's all the natural numbers plus. Okay? And then I think of an even bigger fish. Okay? And he, or she, could eat the whole numbers. And this one is going to be the integers. So this is where we start throwing in those negatives, -2, -1, 0, 1, 2. So I'm thinking about a food chain here. And after the integers, I get, of course, the rational numbers. And we can draw a fin on for the rational numbers here. Big fangs. These are my rational numbers. So they include all of these things and also fractions and then repeating and terminating decimals. Okay? And then this whole ocean is my real number system. And then I have my little oddball out who's not really part of the food chain, and I like to think of him as a starfish or a sea star. And that's my irrational numbers. like square root of 2 and pi. So for me, if I think about this as the sea of reals, so the real number system is everything in the ocean. Natural numbers are the baby fish. Whole numbers are the next biggest fish, integers, and then rational numbers. And then my irrational numbers are the starfish that kind of hang out there by himself. He's the oddball out. So I hope this helps you remember what the differences are between the different elements in the real number system.